Okay guys, welcome to our today's lesson on sequence. Please, if this is your first time of watching, kindly locate the first video so that you can understand the introductory part. So sorry, I'm trying to set the So we are going to look at more examples on finding sequence. In this case, we're going to make use of defined rules. But before we do that, remember in our last class we said that a sequence is a list of numbers generated following a particular pattern. So if I have something like this, we know that from what we did, 5 minus 2 will give us a difference of 3, 8 minus 5 gives us a difference of 3, 11 minus 1 gives us a difference of 3. So if we are asked to generate more numbers, it simply means adding 3 to the previous number to get the current. So 11 plus 3 gives us 14. 14 plus 3 gives us 17, 20, and the list continues. However, today we are not going to look at the listing method. We are going to look at when there is a defined rule stated in the question. So how are we going to approach such problems? Please take your time and follow me to class. Okay, now this is a question we're asked to solve. We're asked to, for all values of n starting from 1 to infinity, find the 9th and 10th terms of a sequence given as 1 5 4 5 9 13 19. Of course, if you see there's already a pattern there. We have 5 minus 1, a difference of 4, 9 minus 5, a difference of 4, 13 minus 9, a difference of 4, 19 minus this. Now we have to be very careful there. So, however, we're not going to keep counting and adding. Assume we're not asked the 9th value. Assume we're not asked the 10th value. Instead, we're asked the 100th value. Is it possible for you to list this within limited time? No. So this is where the rule stated plays a great impact. So this is the general rule guiding the sequence. So we are told that for every an, we should multiply 4 by n and minus a 3. Now remember, we are told that the values of n starts from 1, 2, 3 to infinity. So please, I want us to divert a little bit to be sure that this rule is actually what generated the sequence given as 1, 5, 9, 13, 17. I want us to know. So let's test. When n is equal to 1, when n is equal to 1, it means that wherever you see n, you put 1 minus 3. So in this case, 4 times 1 is 4 minus 3. This gives us 1, which is the first term, right? Let's go again and see how they got this 5. So in this case, n is equal to 1, 2. Remember, this is the second term, so this is the second value for n. And this is going to be 4 into 2 minus 3. And 4 times 2 gives us 8 minus 3, and this gives us 5. And that means the second term is 5. I think we can test the rest and see. Since the first term and the second term, we have generated it from the rule, it means that is the rule for it. So we're asked to get the 9th term. So instead of listing over and over, we are going to apply the rule for the values that we are asked to find. So this is going to be 4n minus 3. But remember, we are looking for the 9th term. Therefore, this is going to be 4 into 9 minus 3. And 4 into 9, that is 4 times 9. They give us what? 36 minus 3. And 36 minus 3 will give us what? 33. It means if we continue with this list, our 9th term will be 33. Feel free to test and see. So this is what we are asked to find. Then we are also asked to find the 10th term. So the 10th term is going to be a subscript 10 equal to 4n minus 3. Where we see n, we are going to put 10. So this is going to be 4 into 10 minus 3. And this is going to be 4 times 10. That gives us what? 40 minus 3. And 40 minus 3 will give us 37. So to easily identify that your answer is even correct, if we go back to the pattern that we had, we discovered a difference of 4, 4, 4, right? So if our 9th and the 10th term we generated 33 and we got as 37, you know 9 is close to 10, right? So subtract this and see if we maintain the same difference. 37 minus 33 gives us the same 4. It means we are correct. So sometimes you don't need to keep on with the listing method. There is always a defined rule. In this case, this is the defined rule that will help us in generating the sequence that we are asked. So let's take a look at example 2. Okay, so this is our second example. We are asked to find the first 5 terms of a sequence defined by the rule an is equal to 5 plus 2n into negative 1 n powered. So the first 5, of course you know that we are counting numbers here, so n ranges from 1, 2, 3, 4 and 5. Please, in this case, I want us to know that the limit for n is defined. That is, we have to start from 1 to the 5th term only. So the rule we are given is an is equal to 5 plus 2n negative 1 to a power of n. So in this case, we are to generate a sequence from the beginning. There's no sequence for us to test, so we are going to generate the sequence by ourselves. So when n is equal to 1, substituting into the formula, we're going to have this is times 1 minus 1 to the power of 1. Remember, anywhere you see n, you replace it by n. That is when n is equal to 1. So a1 is now going to be 5 plus 2 times 1 is 2. Now I want us to take note of this. Anytime that our power is odd, we are going to have a negative number, and anytime it is even, it will change to a positive number. So 1 is an odd number. Minus 1 to a power of 1 gives us minus 1. So we are going to work with this. This is going to be 5. 2 times minus 1 gives us minus 2. And 5 minus 2 will now give us what? A 3. It means in our sequence, our first term is 3. So let's get our second term. That is a2. So putting 2 anywhere you see n, this is going to be 5 plus 2n becomes 2 times n into minus 1 to the power of n, and n becomes what? 2. Remember, I said when the power is an even number, the negative sign will change, because a negative times a negative gives us a positive value. So let's continue. This is going to be equal to 5 plus 2 times 2 gives us 4, and negative 1 to a power of 2 gives us 1. I just explained how it changes. So this is now going to be 5 plus 4 times 1 gives us 4, and 5 times 4 will give us what? 9. It means our second term here is what? 9. Now let's go to the third term, where n is equal to 3. Maintaining the same rule, 5 plus 2n, n changes to 3, minus 1 to the power of what? 3. So this is going to be 5 plus 2 times 3 gives us 6. Remember, a negative number to a power of odd gives us the negative value. So this is going to be 5. 6 times minus 1 gives us minus 6. So I love dealing with this because this is where most people get confused. Remember, the number in the front is having the positive number and the one behind is a negative. And anytime people are confused, I say write it out. Assume you are in a lower grade. So plus 5 means 1, 2, 3, 4, 5. Minus 6 means 1, 2, 3, 4, 5, 6. So cancel each out. Cancel each. Which side is remaining? The negative side. So the result is -1. So here we have -1 in our sequence. So N4. That is the fourth term. Using our rule, we have 5 plus 2n. N changes to 4 times -1 to the power of 4. And this becomes 5 plus 2 times 4 will give us 8. And remember, -1 to a power of even number will turn everything to positive. So this is times 1. So this is going to be 5 plus 8 times 1 is still 8. And 5 plus 8 gives us what? 13. So our fourth number is 13. And of course, let's go to the last one, A5. So using the rule, 5 plus 2n, our n is 5, so this is times 5 into -1 to a power of 5. We are going to have 5 plus 2 times 5 gives us 10. Again, -1 is raised to a power of odd, so this will give us a -1 equal to 5. 10 times a -1 gives us a -10. And if you follow the same explanation I did, you discover that we have a +5 and a -10. So what's the difference between 5 and 10? Or take it backward. 10 minus 5 will give you what? 5. But since the bigger number is having the negative sign, our result will carry the negative value. So our fifth term is -5. So based on the rule, we're asked to generate the first 5 terms of the sequence. And if we obey the rule as it is given, this is the sequence you will generate. So I'm going to drop an exercise on this. And in our next video, we are going to look at how we can apply recursive rule in generating a sequence. Please stay connected because we are going to treat this step by step for better understanding. Thank you once again for following J Maths classes.